A bomb of mass m is at rest. It suddenly explodes into three fragments of mass m by 3 each. First and second moves with velocities v I cap and v j cap respectively. What is the velocity of the third fragment? Initial momentum pi equal to 0 since the body is at rest initially. Let the particles have mass m1, m2 and m3. All the three fragments have the same mass. So m1 equal to m2 equal to m3 equal to m by 3. Now the final momentum Pf is equal to mass of first particle m1 into velocity of first particle v1f, mass of second particle m2, its velocity v2f, mass of third particle m3, its velocity v3f, m1 is m by 3, v1f is equal to v I cap, m2 is also m by 3, its velocity is v j cap. The third particle also has the same mass m by 3. Its velocity is v3f. By law of conservation of momentum, momentum before explosion must be equal to momentum after explosion. That is, Pi must be equal to Pf. Pi is equal to 0 and Pf is equal to m by 3 v I cap plus m by 3 v j cap plus m by 3 into v3f. Now we can cancel m by 3 from the three terms, remaining v I cap plus v j cap plus v3f. v3f equal to, taking this to the other side, minus v I cap minus v j cap equal to minus v into I cap plus j cap. So this is the velocity of the final velocity of the third particle. A body of mass m moving with a velocity v collides head-on with another body of mass 2m at rest. If the collision is perfectly inelastic, what is the fraction of kinetic energy lost in the collision? Before collision, the momentum is Pi, that is mass of first particle m into its velocity v. The second particle is at rest, so its mass m2 into 0. That is Pi is equal to mv. This is the first equation. As the collision is elastic, the bodies move together with a common velocity v after collision. So Pf, that is the final momentum, equal to m plus 2m into their common velocity v, that is 3m into v. By law of conservation of momentum, the initial momentum must be equal to final momentum, that is Pi must be equal to Pf. Pi is mv and Pf is 3m into capital V. So capital V is equal to V by 3. Initial kinetic energy Ki equal to, the first particle has kinetic energy half m v square. The second particle is at rest, so its kinetic energy is 0. So Ki is equal to half m v square. Final kinetic energy Kf is equal to half into, the two particles stick together, so their common mass is 3m and the velocity is capital V. So kinetic energy half into 3m into v square. Instead of v square, we can substitute v by 3. On cancelling, we get 1 by 6 m v square. So this is the final kinetic energy. Fractional loss in kinetic energy is equal to Ki, that is initial kinetic energy, minus Kf by Ki. Ki is half mv square. Kf is 1 by 6 mv square. And Ki is again half mv square. We can cancel m and v square from the numerator and denominator. Rest we have 1 by 2 minus 1 by 6 by 1 by 2. On solving, here we get 1 by 3. So 1 by 3 by 1 by 2, which is equal to 2 by 3. So fractional loss in kinetic energy is equal to 2 by 3.